Okay, this is Mr. Peterson, and we're going over the notes for section 4.5 and 4.6 in Algebra 2. And in this section, we're going to start out with square matrices. A square matrix has the same number of rows and columns. So the two sizes we'll be dealing with in this section have 2 rows and 2 columns, or 3 rows and 3 columns. Those are both square matrices because they have the same number of rows and columns. Okay, we will be spending a little bit of time learning how to find a very specific number that goes along with a matrix. If it exists, this number, we'll call it the determinant, and we'll learn how to find it on both a 2x2 and a 3x3. And then we're going to learn about a special matrix called the identity matrix and what happens when you multiply by the identity matrix. And then we're going to learn about inverse matrices and find out what they are. Okay, first of all, the determinant, and the determinant is a single number. So we're going to learn how to do a 2x2 to begin with. And on a 2x2 matrix, you can see there's 2 rows on this one and 2 columns. You find the determinant by multiplying, it gives you the formula here, A times D, and then you subtract the other diagonal, B times C. So it's AD minus BC, where A is the top left corner and D is the bottom right, B is the top right, and C is the bottom left. Now there's a fairly easy and popular way to kind of remember how to do this. Let me get a different color here. Here we go. If you start in the corner A and you multiply it by D, and then you sweep around and pick up the other diagonal, you get this fish shaped here. And if you put a little I on the fish, you'll remember that you're supposed to use a minus sign in between there. So this is often called the fish number. Now, you have to do it in the right direction. If you go backwards and start on the wrong diagonal, it would look like this, BC minus AD, but that isn't the right one. It's AD minus BC, and you get this fish shape here. It'll boil down to a single number when you actually replace these letters, A, B, C, and D, with values. Now, a couple of things I want to remind you of the name for this value that we're going to calculate. It's called the determinant. And so I'm going to ask you, what type of fish did I draw? Well, if you can determine the type of fish, you'll remember that this is the determinant. This is a goldfish. Can't you see that it's gold? Okay. DET and then the capital A would be the symbol for the determinant. There's another one. You can use what looks like absolute value bars, and they're very similar to the original brackets on the matrix. But if you'll notice up in the corner, the brackets have a little angle on it, and that angle is missing when you put the determinant bars on it. Now, some books will take it a step further. They'll put a double bar on it, and they'll say the determinant of matrix M, for instance, and they'll put the double bars around it. We will use this one the most since it appears on the calculator that you guys use. Okay, so this is a right-facing goldfish. We determine, if I can spell gold, a right-facing goldfish. Obviously, he's gold. Okay, so let's actually get down to doing a couple of these. The first determinant we're going to be doing here would be 4 times 6 would be 24, minus, remember put the minus, negative 3 times 5 is negative 15. So let me write this out. 4 times 6 is 24. And then in the other direction, you get a diagonal of negative 15. And we have a double negative going on here. So that's actually 24 plus 15, which is 39. So the determinant of that matrix is 39. And if we call this matrix A here with a capital letter, then this would be the determinant of A, would be 39. Now notice it's not a matrix, it's a scalar. Okay, here we go. Oh, by the way, did you determine what type of fish that was? It's, let me draw its blue fin here, and you'll know that it's a bluefin tuna. Okay, so next we're going to find this next one here. Oh, hang on. I got to get the right color on here. Let's see here. I don't know. What do I want to use here? I'll go with a red fish. I'm not sure there is a red fish, but anyway, multiplying those two first gives 18 and then minus 8. So we get 18. I like to put these in parentheses in case it turns out to be a negative. And in the other direction, you get 8. So the determinant of this fish is 10. And this minus sign is missing here. It's the eyeball. Okay, so 18 minus 8 is 10. The determinant of matrix B is 10. So if this were matrix B, capital letter there, then I could do this. The determinant of B is 10. Okay, this next one here, let's color it purple. I'm not sure there is a purple fish, but we're going to make one up here. Negative 12 minus negative 12. 6 times negative 2 is negative 12, and the same value in the other direction. And when we take care of this double negative here, you get a determinant value of 0. And I believe that ends page 1 of our notes, and we'll continue on the other side.